Okay, 7-90 says a rectangular piece of cardboard has a perimeter of 24. The cardboard is creased in such a way that it can be folded to form a square tube with ends open. At least they gave us a diagram. Write an equation for the volume of the box in terms of H and X. So, volume, I know that volume equals base area times height. So my base area, yeah, I think it would be like, because my base is going to be like this square, so to x squared times height. So, and that's exactly what they have there. So that makes sense. And then now write the volume of the box using only x. Well, we know something about this 20. We got this 24 here. Yeah, so we know this is 4. This is 4x, and this is 4x, and this is h and h. So I know 4 plus 4 is 8. 8x plus 2h. I don't know if this is going to help. It was 24.
2 times 4x plus h, so I could just take the 2 out easy. Just 12 equals 4x plus h. Then I got h equals 12 minus 4x.
Ah, you're so smart. So you got the 12 from... Sorry, I got confused.
I just divided everything by 2, because you said it was 8x plus 2h.
Oh, so you said it was 4x plus h equals 12?
Yep, and then you just get h equals 12 minus 4.
Oh, you're so smart. Yeah, okay, so h...
plug that into x squared, and then you put that instead of h.
Yes, that sounds very nice. So let's do that. So now write the volume. Okay, so we're just, instead of h, we're using the 12. So let's see. Like that. Okay, and you could multiply it out if you want to. The book didn't. What is the appropriate domain for the function you wrote in part B? So you don't want negative stuff. So the function I wrote in part B. So
x is greater than or equal to 3.
Did you do that by setting this greater than or equal to 0? Is that how you got that?
I just thought the 12 should be negative, like the part with the 12 in it, and so 4 times 3 is 12.
Oh, you guys are amazing. Thank you. Yeah. Yeah, it has to be greater than or equal to 3, or else that'll zero out, right? Okay. So, and x can't be 0 because that will zero this part out.
It's greater than 3.
Well, it says x has to be in between 0 and 3. So I think what I would have done, I don't know, is this the silly to do this? I would say that this volume has to be greater than or equal to 0. And I would have solved it. So that means x, well then I would have used 0 product property, I guess, since x squared is, so, well that just means x is equal to, like even if I square root of both sides or whatever, x has to be greater than or equal to 0. And then, or it can't even be 0 because then I have, because you can't have a 0 volume, right? So maybe I don't even want it to be equal to. And then I think it's the same thing, like, and then I would have set that.
It actually shouldn't be greater than 3 because
It's less than 3.
yeah.
Because I just, yeah.
Because it's subtracting the 4x, so if it was like...
Because I just did, since we can already assume that it's greater, or, yeah, it's greater than 0, I just put x squared times 12 minus 4x is greater than 0, and then I just solved that and got, well, you divide the x squared out, that doesn't do anything, so you got 12 minus 4x equals 0. And then you do 12 is greater than 4x, and then 3 is greater than x.
Because if you had, like, 4, then you'd get a negative number in the second part, and then you multiply, and then you get a negative value. So
yes.
That has to be in between 0 and 3.
Okay, yeah, that's another good reason why it has to be, so that we can restrict the domain to that. And then the last part says graph the volume function and locate the point that represents the maximum volume. I would actually just go on Desmos, and because it's going to be a cubic, and I would go on Desmos and graph it. And I'm not sure what it looks like, but however it looks, there's going to be like a high point. You know what I mean? Local maps or whatever. And so that will give you the maximum volume. So just get it on Desmos.